In this video, we're going to be talking about probabilities in which you needed to be able to count a little bit better from the previous videos. So if you still have trouble counting, figuring out combinations and permutations, probably go back and look at those videos again. Otherwise, we're going to go ahead and go forward, and we're going to start off nice and simple. Let's say you're rolling a dice. Your basic die, 6 sides, and it has the numbers 1 through 6 on it. And we'd say, what's the probability of rolling a 2? That's what this means. What's the probability of rolling a 2? That's how you can actually write it. Well, the probability of doing that is always going to be, there's 1, 2 on the dice, and there are 6 outcomes, so it's 1/6. That's the probability. You can convert that to a percentage. If you're not sure how to do that, go back to the other video and check out the percentage. In comparison, if I were to say, what's the probability of rolling, say, a 2 or a 3 on this dice? Well, that would be 2 outcomes out of the 6, so of course that would be 2/6. Of course, you could simplify that to be 1/3. Now, this is the point where you need to stop and ask yourself, do you understand? Stop. Do you understand? If not, think about what we're doing here and look at it again. Go back and watch this part again, but don't go forward unless you understand this basic example. Okay, move. Next, we're going to say, let's pretend that you have a bunch of cards. You have baseball cards, you have hockey cards, and you have soccer cards. Okay, 3 different types of cards: baseball, hockey, and soccer. And you have 8 baseball cards, you have 5 hockey cards, and you have 6 soccer cards for a total of 19 cards. Okay? Now, if I were to say just what's the probability if you had all these cards stacked together of drawing a baseball card, the probability of drawing a baseball card, you would say something like, oh, well, that's 8 out of 19 total cards. 8 out of 19 would be the probability. But what would the probability of drawing, say, a hockey card? That would be the hockey card. Well, there are 5 out of the 19 cards, okay? So now we would say, what's the probability? I'm going to actually shrink some of the probability of drawing a baseball or a hockey card. Okay. Now this one here gets a little bit more interesting. So let's shrink this stuff down and let's look at that. Here there are, in essence, it's a winner. I get it if I get any of the 8 or 5. So what we're doing, we're just adding things together in this case. So if we want to talk about what's the probability of doing this baseball or hockey in the deck, you would say, oh, well, what's 8 plus 5? That's 13. So you would say 13 out of 19 would be the probability of doing that. So you go, yay! And now, again, I'm going to tell you to stop. Question yourself. Do you understand what we just did? Again, this is basic counting, and I want to make sure that you're okay with this. If you have questions, you got to stop and you got to go back. Okay, in this next piece, I want to talk about 2 different sort of ideas. The first is called mutually exclusive. If I were to ask you a question about drawing a king or a queen, hopefully you could say the probability of getting a king or a queen. Well, there's no overlap in these 2 worlds. Therefore, they are what's called mutually exclusive. There's no overlap. They are completely separate. You would say, well, what's the probability of getting a king? And then add that to the probability of getting a queen. And hopefully you know that the probability of getting a king would be 4 out of 52 plus another 4 out of 52. So the total probability of getting a king or a queen would be, well, there are 8 total out of 52. So now I want you to, again, stop and look at this slide again. I covered a lot of information in a short amount, so play it again. Rewind, play it again, and look at it. Did you understand this? Okay, now on this example, the question would be, what is the probability of getting a king or a spade? This is different than before because you see I have the kings, but then I have all of the spades in the deck, of which the king of spades is a spade in the deck. So now you see this overlap. When you get this overlap, this is called not mutually exclusive. And I would say the only reason that this is, well, let's see if I can shrink this all down and make it actually work. Let's put that there. There we go. The only reason that this is really relevant is because when you calculate it, you can't say, well, there are... So of course we can look at the where's my marker? The probability of having a spade that's upside down. The probability of having the spade would be 13 out of the 52 because there are 13 spades in a deck. And the probability of having a king would be 4 out of 52. But unlike before, we cannot add them, okay? You can't just add them and come up with 17 out of 52 because you have some overlap. So you actually need to take that into account. So you would add them and then subtract your overlap is what you end up doing. You would say, well, I need the probability of the, again, I drew that upside down. You would need the probability of the spade plus the probability of all of the kings minus the kings that are spades, right? And I'm going to go write them like this. The kings that are spades. So what you actually end up with doing is the 13 over 52 plus 4 over 52. And then you have to subtract back out the overlap, which is 1 out of 52. Of course, there's a couple other ways you could think about so that the actual answer there would be 16 out of 52 would be the correct answer. There's other ways you could think about it. You could just go, well, there are 12, you could say, oh, this is 13 cards plus these 3. That's fine. Or you could say there are these 4 plus 12 others. That'd be fine. But bottom line, when you are not mutually exclusive and you have overlap like this in the middle, you have to be careful to subtract out that stuff. And that's just the sort of question they might throw it on the ACT just to trick you. But now we're going to go on to some problems that you can try on your own. Okay, so with these ones that I want you to do on your own, do these on your own. First, roll 2 dice. And then what is the probability? So the sum of those 2 dice is equal to 10. So you're going to have to think about how many different ways could you roll 2 dice and get the sum equal to 10. You also have to figure out how many total combinations could you actually get with 2 dice. So you have to go back to the combinations video and figure out how many total combinations you could actually end up with. The answer is you could get 36 different combinations, but I need you to think about how that came to be. So it's something over 36. The next one is draw 1 card from a deck. What's the probability that you're going to get a 3 or a 4? So think about what's in a deck of cards. If you don't know, ask the person around you. If they don't know, get out of your seat and go and ask the substitute or the teacher how many threes are in a deck, how many fours are in a standard deck. The next question is the probability of threes or hearts. So be careful. This one is a not mutually exclusive, so be careful not to overcount. There's a couple more problems on the next page. Okay, so in this question, let's look at it carefully. In a class, you have 10 freshmen, 8 sophomore, and 2 juniors. Now, of those 10 freshmen, 9 freshmen, 2 sophomores, and 1 junior are all girls. So that means that there's 1 boy freshman. That would mean there are 6 boy sophomores and 1 boy junior, right? So again, listen to what I said, repeat it and rewind it, and understand the information here. You can't do the question unless you understand so go back and listen to it again. Now, what's the probability? The first question is, what's the probability that you could choose, if you're going to go and select someone from the class, a name at random, that you would get a freshman or a girl? Okay? Be careful for your mutually exclusive. You're going to have to think about this one. The second question is, what's the probability that you would get a sophomore or a male? So you're going to need to think about how many overlaps do you have? What's the probability of your freshman? What's your probability of being a girl? What's your probability of sophomore? What's the probability of being a boy, which is the opposite of, if you're not a girl, you must be a boy. These are all your girls. But then make sure you cross out or subtract your duplicates. Okay, this is a tricky one. Go slowly, think about it, have fun, and make sure you turn in all of your notes.